Hello students, myself Hema Marwah, your chemistry teacher is again here to represent the lesson 5 titled The Language of Chemistry for the class 8. So let us start the chapter with introduction of language of chemistry and other topics of the chapter. Students, the language of chemistry is different from ordinary language. Instead of using words and sentences, we use symbols, formula, and equations in chemistry to represent substances and the changes they undergo. J. Berzelius laid the foundation of chemistry language in early 19th century and later it was modified gradually into present form. Now we will know what is a symbol and what does it represent. A symbol is an abbreviation for the name of an element. I repeat, a symbol is an abbreviation for the name of an element. The symbol of an element represents the following. It represents an element in particular and it represents an atom of an element. Now, in this slide, we will know the symbols of different elements, how they are derived. Symbols of different elements have been derived in three ways. The first way is that the first letter in capital of the English name of an element is being taken. Hydrogen, say for example, hydrogen, the symbol is capital H. Boron, capital B. Carbon, C. Nitrogen, capital N. Oxygen, symbol is O. Fluorine, capital F. Phosphorus, P. And sulfur, S. In some cases, scientists they have taken first letter along with one more letter of the English name of element. Say for example, helium, the symbol is He, neon, symbol is Ne, nickel, Ni, magnesium, Mg, manganese, Mn, aluminium, Al, and others. In some cases, the symbols are being chosen from one or two letters of the Latin name of an element. Say for example, sodium, the Latin name of the sodium is natrium. So the first two letters are being chosen and hence the symbol is Na. Potassium, Latin name is kalium and first letter is being chosen as K. So the symbol of potassium is K. Iron, the Latin name is ferrum and the symbol is Fe and others. Now we will know what is formula. The formula of a molecule gives the number of atoms of the same or different elements present in the molecule. In other words, it tells how many atoms of which elements have combined together to form the molecule. For example, N2, O2, H2O, CO2. In the case of N2, this is the one molecule of element nitrogen. Here, two atoms of nitrogen are combined to give you one molecule of the element nitrogen. In case of water, that is H2O, here you must have noticed that two atoms of hydrogen and one atom of oxygen are combined to give you one molecule of the compound water. Now we will learn how we can write the formula of elements. But before that, we should know molecule of an element. When an atom of an element combines with another atom of same element, a molecule of the element is formed. Point to be noted, to write the formula of the elements, we should know the atomicity of the molecules. Now we will know what is atomicity of the molecule. The number of atoms contained in a molecule is called the atomicity of the molecule. I repeat, the number of atoms contained in a molecule is called the atomicity of the molecule. According to the number of atoms found in a molecule, molecules are monoatomic, diatomic, triatomic, and so on. For example, monoatomic molecules, they are helium, neon, argon. All the noble gas elements are monoatomic molecules. Diatomic molecule, examples, nitrogen, oxygen, chlorine. Triatomic molecule, ozone. Now we will know what is the valency of an element, because valency we should know for writing the chemical formula for the compounds. When we will write the formula of a compound, then we should know the valency of an element. So everybody should be acknowledged with the valency of an element. So what is valency? The combining capacity of an element with other elements is known as its valency. In other words, it is given by number of hydrogen atom that one atom of an element combines or displaces from a compound. Elements with valency 1 to 3 are said to be monovalent, divalent, trivalent, respectively. So in our book, there is a table in which they have shown the valencies of first 20 elements which the students are expected to learn. So here I have shown a glimpse of it also. This table shows that the hydrogen, lithium, sodium, potassium, they have the valency of 1. Beryllium, magnesium, calcium, they have the valency of 2. Boron, aluminum, they carry the valency of 3. Carbon, silicon, they have the valency of 4. Nitrogen, phosphorus, they have the valency of 3. Oxygen, sulfur, they have the valency of 2. Fluorine, chlorine, valency is 1, and helium, neon, argon, which are the noble gas elements, they have the zero valency. So students, you are supposed to learn the valencies of first 20 elements. Now we will learn how to write the chemical formula of compounds. The formula of a binary compound is obtained by transposing the valencies of constituent element. Say for example, in case of sodium oxide, sodium carries a valency of 1, oxygen carries a valency of 2. When you will transpose the valency, you will get the chemical formula as Na2O. In case of calcium chloride, calcium carries the valency of 2, chlorine has a valency of 1. When you are going to transpose their valencies, you will get the chemical formula as CaCl2. But there are certain elements which show variable valency. For example, copper shows a valency of 1 as well as 2. Iron shows a valency of 2 as well as 3 in certain compounds. Phosphorus shows a valency of 3 as well as 5. So how we can write? We can write the valency, we can write the chemical formula of such compounds by writing their valencies in the Roman numeral in the name of compound. Now we will know what is a radical. A radical is a kind of entity that can be an atom with a charge on it or a group of atoms behaving as a single atom with a charge on group. It has a valency which is the same as its charge without sign. Chemical formula of compounds containing radicals is obtained by transposing the valencies of radicals and dividing the numbers of radicals by a common factor, if any. Here are certain examples of compounds containing radicals. Say for example, sodium hydroxide, chemical formula is NaOH, potassium nitrate, chemical formula KNO3, sodium hydrogen carbonate, chemical formula NaSCO3, and others. So you have to learn all the chemical formulas which are given in this PPT. Now we will know what is a chemical equation. A chemical equation is the representation of a chemical change in the form of symbols and formula of substances undergoing change. Hence, in other words, all chemical reactions are represented by chemical equations which uses formula and symbols of substances involved in chemical reaction. The starting substance which react to produce new substances are called reactants, while new substances formed are called product. Reactants are always written at left hand side, which you can represent as LHS, whereas products are written at right hand side, which you can represent as RHS. Students, now we will learn the steps of writing chemical equation. Chemical equations are written in following steps. First step, writing the skeleton of the equation by writing symbols and formula of reactants on left hand side and those of product on the right hand side. For example, carbon when burned in a sufficient supply of air forms carbon dioxide. So the skeleton of the equation will be C plus O2 on the left hand side and the product form, that is carbon dioxide, on the right hand side. Students, now after writing the skeleton of the chemical equation, the second step is balancing the chemical equation. But the question comes in the mind, why we need balancing of chemical equation? All of you know, according to the law of conservation of matter, the matter can neither be created nor destroyed. Thus, nor can be atoms. So, no atom are lost or gained in a chemical reaction. So, number of atoms of each element on the reactant side must be equal to the number of atoms of each element on the product side. So to show this equality, we need the balancing of chemical equation. So what is a balanced chemical equation? A chemical equation in which number of atoms of each element on the reactant side is same as that on the product side is called the balanced chemical equation. Hence, after writing skeleton, count the number of atoms of each element on both sides. If and they are equal, equation is balanced. In case they are unequal, make the number of atoms equal using proper coefficient. Now we will take one example to know how to balance chemical equation. You know, carbon when burnt in sufficient supply of oxygen gives carbon dioxide. So we can write skeleton of this chemical reaction or chemical equation as C plus O2 gives you CO2. Is it balanced? Yes, because number of atoms of carbon and oxygen are equal on left hand side as well as on right hand side. You can count them and you can write in a tabular format. Then you will see both of the atoms are equal on both sides. So you can say this equation is balanced. Students, to add your knowledge how to use coefficient in a chemical equation, I have included one more example. The example is the following equation balanced? If it is not, balance it. H2 plus Cl2 gives you HCl. So now what steps you have to follow? First step, you will count the number of atoms on both sides, that is on the left hand side and on the right hand side. So you will find in this case on the left hand side you have two hydrogen atoms, two chlorine atoms, but on the right hand side they are one only, means hydrogen atom is also one and chlorine atom is also one. Now in second step we will try to equate the number of atoms on both sides. So how you can do it? You can do when you will place the coefficient 2 before the product. So the equation will be H2 plus Cl2 gives you 2HCl. So when you will count the number of atoms on both sides, that is on the left hand side and the right hand side, you will find the number of atoms are equal. That means the numbers tally. So therefore you can say the balanced chemical equation for the given reaction is H2 plus Cl2 gives you 2HCl. Now the last topic is how we can make a chemical equation more informative. A chemical equation can be more informative if we mention the conditions under which a reaction takes place. Mostly it is being mentioned on the arrow. When we mention catalysts used in the chemical reaction, states of reactants and products, for example, if we want to show the solid state, that will be shown with small s letter within the round braces. If we want to show the liquid state, that will be shown with the small l letter within the round braces. And if you want to show the gaseous state, it will be shown by small g letter within the round braces. Then name and the color of substances also you can mention in your chemical equation. Thanks for watching my video. I hope my videos will help you in enhancing your interest and knowledge in chemistry.